Hi, my dear students. Welcome to India's biggest online platform, Manifold Institute Gate Classes. Today, we are going to discuss a very interesting topic, hydrostatic forces on surfaces. In this session, we can discuss some problems based on hydrostatic forces on surfaces. Let's start the session. See here, a 4-meter long quarter circular gate of radius 3 meter and of negligible weight is hinged about its upper edge A. Here, weight of the gate is neglected. Okay, so as shown in the figure below, here hinge point is A. The gate controls the flow of water over the edge at B. Okay, na? So where the gate is pressed by the spring. Here, gate is pressed by the spring. The water level rises to A, up to here at the upper edge of the gate. Here, total water present here. This is the water present here. Now, we need to assume the hinge is frictionless, weight of the gate is negligible, density of water 1000 kg per meter cube, G equal to 9.81 meter per second square. Finally, we need to determine minimum spring force required to keep the gate closed. Okay, so minimum amount of spring force we need to determine. For that, you need to draw free body diagram for entire system. Then you can apply equilibrium equations to determine the magnitude of spring force. For that, first we can determine hydrostatic pressure force acting on the curved surface in x direction. After that, hydrostatic pressure force acting on the curved surface in y direction. Both we need to determine. After that, line of action or point of action of the FH and FV we need to determine. Then you can draw free body diagram for the given system. As a first step, you need to determine hydrostatic pressure force acting on the curved surface in x direction. For that, we need to do projection, horizontal projection. Once you project horizontally, you will be getting a rectangular cross section. Here, width of the gate is given as 4 meter and the radius equal to 3 meter. Now, what is FH or Fx? That is up to you. FH equals to rho G into AH bar. Rho G into AH bar. This is acting at center of pressure. Okay, so H star we need to determine. Okay, so here what is A? Tell me. What is A? 4 meter into 3 meter, 4 3 ja 12 meter square, and H bar equals to, what is H bar? Distance from the free surface to center of gravity. From here to here we can see that this is equivalent to H bar. H bar equivalent to 1.5 meter. 3 meter by 2 is equivalent to 1.5 meter. 1.5 meter. Now tell me, what is the magnitude of hydrostatic pressure force acting on the curved surface in x direction? 10 cube kg per meter cube into 9.81 meter per second square. What is the area? 12 meter square into H bar is nothing but 1.5 meter. Now tell me the magnitude of FH in terms of kilonewton. Tell me 9.81 into 12 into 1.5 meter into 1000. So here 176.58. Okay, so finally we will be getting 176.58 kilonewton. That is the magnitude of FH. Okay, so now tell me, what is the location where it is acting? It is acting at center of pressure. Then determine H star. Just now we determine H star is nothing but 2h by 3. 2h by 3. So what is h here? 3 meter. 3 meter. Correct na? 3 meter is the h. 2 times 3 meter by 3 equals to 2 meter. So you will be getting h star equal to 2 meter. Fh or horizontal force acting along x direction, that will be 176.58 kilonewton. Now coming to the vertical force. How to determine vertical force? Okay, force acting on the curved surface in y direction. Okay, so how to determine that? Tell me how to determine. Okay, Fy or else Fv. Fv is equal to weight of the fluid displaced. Okay, na? Clear na? Weight of the fluid displaced, because fluid present below the gate. Because of this fluid will exert some buoyancy force on the curved surface. Okay, curved surface experiencing the buoyancy forces because fluid present below the curved surface. What is the buoyancy force? How to determine buoyancy force? Here, weight of the fluid displaced. Weight of the fluid displaced. Clear na? Weight of the fluid displaced. How to determine that? Density of the fluid. Okay, that is water, of course. Here density of the fluid is water into volume of the fluid displaced into G. How to determine volume of the fluid displaced? Here Fv is acting vertically upward direction because buoyancy force always act vertically upward direction. So how to measure the volume of the fluid displaced? Okay, to measure volume of the fluid displaced, first we need to determine area. So for that we need to project the area from curved surface to the free surface, because vertically upward direction, from curved surface to the free surface. This is equal to A star. How to determine A star? What is A star? Tell me. How to determine A star? Tell me. Is equivalent to total area minus this particular quadrant circle. Okay. Total area is how much? So this will be 3 meter. This is also 3 meter. So it's a square. Okay. So total area 3 meter into 3 meter minus pi r square by 4. Pi r square by 4. Clear na? R is equal to 3 meter. So now tell me here. This is equivalent to R into R square. Correct na? So 3 into 3, 9 meter square minus 5 times 3 square by 4. That is dash meter square. A star is equal to dash meter square. Now tell me, what is the magnitude of Fe? Tell me. 10 cube. Here what you people will get? Density of the fluid into A star into width of the gate. Here that will be B or width of the gate, that is up to you, into G is equivalent to rho. A star is nothing but R square. Here I want to keep capital R. That is up to you. R square is the area of the square minus pi times R square by 4. Pi times R square by 4 into width of the gate into G. Once you substitute all, you will be getting the magnitude of Fv. So here, what is the magnitude of Fv? Tell me. Is equal to 10 cube kg per meter cube into r square is nothing but 3 meters square minus pi times 3 meter whole square by 4 into width of the gate. What is the width of the gate? 4 meter is the width of the gate. 4 meter into 9.81 meter per second square. Finally, dash kilonewton. Fv is equal to dash kilonewton. Calculate and tell me. Here 9 minus pi times 9 by 4, okay, into 4 into 9.81 into 10 cube. Here you will be getting 75.78. 788 kilonewton. What is A star? Tell me. What is A star? What is A star? Into 9 by 4 plus 9. 1.9314 meter square. This is the value of Fv. Now, a very important topic here is how to locate the Fv. Okay, now we can determine the location of vertical force acting on the curved surface. For that, we need to apply moment of area about hinge A or OA or O. That is up to you. Okay. So now how to apply moment of area? First consider total area. Here we are having two cross sections. One is A star and A, and total square. Okay, na? So can I say this? Moment of area of the square about point A equivalents to sum of the individual moment of areas about point A. Okay, so for that I will tell you moment of area of the square. Moment of area of the square about point O. About point O or about point A, that is up to you. Moment of area of the square. Moment of area means what? Area into perpendicular distance. Moment of a force means force into perpendicular distance. Similarly, moment of area means area into perpendicular distance. First consider total square. Okay, moment of area of the square. What is the area of the square? A plus A star. Moment of area of the square. That means here what you will get? Exactly at the center, na? Total square. Centroid will be exactly at the center. This distance, tell me, r by 2 into r by 2. Correct or not? Into r by 2. You are taking moment about OA or moment about A. That is up to you. Okay? So that is equivalence to, now we need to take individual moment of areas about point A. Okay, so here first take A moment of area. Okay, now A about point O or about point A. This distance will be 4r by 3 pi. This distance will be 4r by 3 pi. Now, moment of area of this particular A star about point A, that will be X star. Moment of area A star into X bar. Okay, so that is the thing. Here, how to determine X bar from here? That we need to calculate. So here A plus A star is nothing but A plus A star is nothing but, tell me, total area of the square you will be getting. So that is equivalent to r square. That is area of the square. Now into r by 2. Understood or not? First consider total square. Square consists of two portions. One portion area is A. Next portion area is A star. Okay, na? Now, moment of total area means consider total square. Okay, represent the centroid of total square. Centroid of total square. Okay, so we need to take A plus A star. Moment of area means A plus A star into distance between the this particular plane OA. Perpendicular distance only need to take. That will be R by 2. So after that is equal to individual moment of areas. Individual moment of areas. That part tell me. Individual moment of area means A. A into centroid of this particular portion. Centroid of this particular portion from here to here it will be 4R by 3 pi. After that take another portion. So that is A star. Moment of A star about point A, X star. That's it. Clear na? A star into X bar is equivalent to what is A? Tell me what is the area A? Pi times R square by 4. Pi times R square by 4. That is the area. So what is the area into 4R by 3 pi na? Into 4 times R by 3 pi. 4 times R by 3 pi plus A star. A star is nothing but just now we are determined. This is X bar. Finally, what is X bar? X bar equivalents to R cube by 2. R cube by 2. This will be minus pi gets cancelled out. 4 gets cancelled out. Finally, how much you will be getting? 4 pi. R cube by 3 you will be getting. R cube by 3. Correct? So this part R cube by 2 minus R cube by 3 by A star na. A star is nothing but total R square minus pi R square by 4. Correct na? Okay. A star is nothing but R square minus pi times R square by 4. Like this, we need to determine the location of vertical force acting on the curved surface. It's a good point actually. Okay. So here R square gets cancelled out. So total R square now. Finally, what you will get? R by 2 minus R by 3 by here 1 minus pi by 4. 1 minus pi by 4. Here X bar tell me. Finally, what is X bar? X bar equivalents to. So here 6 na. Here you will be getting 6. So 3R minus 2R. 3R minus 2R by here 4 minus pi by 4. Okay. So finally what you will get? R by 6. Here R by 6 into 4 by 4 minus pi. So 2R by 3. 2 times R by 3. 4 minus pi. Okay. So X bar equivalents to 2 times R by 3. 4 minus pi. R is equal to 3 meter. That is why finally what is X bar? Here X bar tell me. X bar equivalents to R equal to 3 meter na. R equal to 3 meter. 3 gets cancelled out. 2 by 4 minus pi. 2 by 4 minus pi. 4 minus pi into that is 2. So 2.3298. Okay. So X bar equal to 2.3298 meter. Okay. That is X bar. It is very important discussion. X bar you are getting. Now we can draw free body diagram. Okay. So here, see here. So because of this particular gate na, so here that particular this spring will be compressed. Okay, na? So compression in the spring you will be getting. Spring force always act opposite to the direction of deformation in the spring. Correct na? So compression in this particular direction, then spring force will be acting opposite to the direction of deformation in the spring. That is why spring force will be acting in this particular direction. So that is the direction of spring force. Now we have drawn free body diagram for the curved gate, curved surface. Now we can apply moment about A, moment about hinge. So how much, what is the thing, tell me? FH, moment of FH about point A, clockwise or anti-clockwise? Anti-clockwise. Moment of FE about point A, anti-clockwise. Moment of FS about point A, clockwise. Okay, sum of the clockwise couples equal to sum of the anti-clockwise couples. Now tell me, FS into radius, na, that is the moment of spring force about point A. That is Fs into radius, that is clockwise, is equivalent to Fh into Fh into H star. You are applying moment about hinge. Okay, so plus this is also anti-clockwise, moment of Fe, moment of Fe into x bar. So that is why you calculated Fh, the magnitude of horizontal force, location, and magnitude of Fe and location of Fe. Everything you calculated, substitute all the values in this beautiful expression. Finally, you will be getting the magnitude of spring force in terms of kilonewton. Okay, so just tell me, what is Fh? What is Fh in terms of kilonewton, and H star in terms of meter? You calculated. Fv in terms of kilonewton, x bar in terms of meter. So what is the magnitude of Fh? Tell me. You only calculated. What is the magnitude of Fh? 176.58. 176.58 kilonewton. Okay, so H star is nothing but 2 meter, and Fv, tell me, what is the magnitude of Fv? 75.788. 75.788 kilonewton. X bar is nothing but tell me 2.3298. 2.3298 meter. Now just substitute all the values in this beautiful expression. Fs into 3 meter equals to Fh is nothing but 176.58 kilonewton into 2 meter plus 75.788 kilonewton into 2.3298 meter. Finally, what is the magnitude of Fs? Here both are kilonewton. That is why you will be getting Fs in terms of kilonewton. Calculate and tell me. 176.58 into 2 plus 75.788 into 2.3298 divided by 3, you will be getting finally 176.57. 176.57 kilonewton. That is the answer. 176.34 kilonewton. So here, what is the magnitude of spring force? Tell me. Spring force equals to 176.57 kilonewton. Understood, na? So this is the answer. So In this problem, you calculated FH and H star, FE and X bar. Here, determining X bar, it's a good concept. Okay. So here finally you got Fs equivalents to 176.57. It's almost equivalents to, so it is 57 kilo Newton. Clear? Finally, you got the answer. Okay.